Greetings and welcome to the Dr. J Vlog series. It is Monday, June 16th, 2025, and on Mondays we talk about mathematics and statistics. So each Sunday I'm introducing a new theme of the week covered from 7 different and yet typically complementary angles or perspectives. Last week we looked at the world's oceans. This week's focus is the sun. So yesterday I discussed the sun in relation to my philosophical views of the meaning and purpose of life. Today I'm honing in on some key statistics to help us make sense out of the star of our solar system, better known as the sun. So let's dive in and discuss some fun facts about the sun, or let's just call them sun facts. So sun fact number 1, first and foremost, our sun is perhaps 4.6 billion years old. It's the yellow dwarf star at the center of our solar system. And it's responsible, of course, for holding everything together, thanks to its massive gravitational pull. Sun fact number 2. Indeed, it's unequivocally the largest object in our solar system, with a diameter of about 865,000 miles, 1.4 million kilometers. By comparison, the Earth's measures only about 7,925 miles in diameter. And so that means you could actually line up 109 Earths side by side, touching each other, and you just about span the width of the sun. Sun fact number 3. What if you wanted to circle the sun, and the Earth for that matter? So the Earth's its circumference is just under 25,000 miles, or just over 40,000 kilometers. So driving at 100 kilometers per hour, it'd take you how many hours then to circle the globe if there were just such a highway available? We'll do the math. It's 400 hours of non-stop driving, or about 16 2/3 days. But the sun's gargantuan in comparison. Over 2.7 million miles in circumference, or 4.37 million kilometers. So again, driving at 100 kilometers per hour, it would take you a whopping 43,700 hours to circle the sun, driving at 100 kilometers per hour, or 1,821 days, or in other words, just under 5 years. Sun fact number 4. And yet, when I think about what's most remarkable about the sun's size, I think of this, the fact that it contains over 99.8% of the mass of the entire solar system. The equivalence of the weight of about 330,000 Earths. Just incredible. Sun fact number 5. The sun's located about 93 million miles from Earth, or about 150 million kilometers. And of course, it provides all of the energy that's necessary to sustain life on our planet. And so, but at the same time, it takes that sunlight, because of that distance, to about 8 minutes and 20 seconds to reach us. Again, traveling at 300,000 kilometers per second, the speed of light. Sun fact number 6. Most of you probably know that the hottest part of the sun is its core. Temperatures topping 27 million degrees Fahrenheit, or 15 million degrees Celsius. The sun's surface, the photosphere, which I'll come back to in a moment, is a relatively cool 10,000 degrees Fahrenheit, or about 5,500 degrees Celsius. But there's an interesting mystery that we're also going to address, at least in part, on Thursday, and that is that the sun's outer atmosphere, the corona, gets hotter as it stretches away from the surface of the sun. And the corona reaches up to 3.5 million degrees Fahrenheit, or about 2 million degrees Celsius, far exceeding that of the photosphere. We don't know exactly why that is. Sun fact number 7. The sun orbits the center of the Milky Way. You probably knew that. And of course, as it does that, it's dragging along all of the other planets and the asteroids and comets and whatever objects happen to be within its gravitational pull. And then that leads to sun fact number 8, which is that our solar system is moving at an average velocity of about 450,000 miles per hour, or 720,000 kilometers per hour. And as fast as that is, and that's pretty doggone fast, it still takes roughly 230 million years for the sun to make one complete orbit around or complete trip around the Milky Way. And so even though technically we come back to roughly the same place each birthday, at least relative to the sun, we've already moved with the sun about 7 billion kilometers in that same year. So again, that's in terms of its orbiting or its movement through the galaxy. And so in other words, we'll never truly physically come back anywhere exactly to the same place again within the galaxy. There's something kind of bittersweet and poetic about that fact. Anyway, sun fact number 9. We don't have any neighbors that are really close by. That is, the sun's nearest stellar neighbor is Alpha Centauri, or the Alpha Centauri triple star system, which consists of the red dwarf star Proxima Centauri, which is about 4.24 light years away, and then you've got Alpha Centauri A and Centauri B, two sun-like stars that are orbiting each other, and they're about 4.37 light years away. As a reminder, a light year is the distance that light travels in 1 year, which is the equivalence of about 6 trillion miles, or about 9.5 trillion kilometers. Sun fact number 10. The sun rotates on its axis as it revolves around the galaxy, and its spin has a tilt of about 7.25 degrees with respect to the plane of the planet's orbits. And since the sun is not solid, of course, the different parts of the sun rotate at different rates. So, for example, at the equator of the sun, it spins around once about the equivalence of every 25 Earth days, whereas at its poles, the sun rotates once on its axis about every 36 Earth days. Sun fact number 11. And we're going to do 20 of these, so we're halfway there. The sun is a huge ball of mostly hydrogen, almost 3/4, and helium, almost 24%, with the remainder a variety of other metals, heavier metals. And as the sun continues to burn and fuse the hydrogen, scientists estimate that the sun will have completed that fusion process in about another 5 billion years. And so that's not something we're going to have to worry about, per se, in our lifetimes. Sun fact number 12. The sun has several regions. The interior regions include the core, which I just mentioned, the radiative zone, and the convection zone. And then as one moves outward, we arrive next at the visible surface of the photosphere, then the chromosphere, then the transition zone, and then the corona, the sun's expansive outer atmosphere. Sun fact number 13. Once material leaves the corona at supersonic speeds, it becomes the solar wind, which forms a huge magnetic bubble around the sun called the heliosphere. And the heliosphere extends beyond the orbit of the planets in our solar system. And so the Earth then exists inside the sun's atmosphere. And then outside of the heliosphere, of course, is interstellar space. Sun fact number 14. Energy from the core is carried outward by radiation. And this radiation bounces around the radiative zone, and it takes a whopping, this is incredible, about 170,000 years to get from the core to the top of the convection zone. Okay, sun fact number 15. The sun, of course, you probably know this as well, does not have a solid surface like the Earth and the other rocky planets and the moons and so on. And as such, the part of the sun that is commonly called its surface is known as the photosphere. And that's the part that we see from Earth with our eyes. Just be sure not to look directly at the sun, or if you do, make sure you're wearing protective eye gear. Sun fact number 16. The sun generates magnetic fields that extend out into space, forming the interplanetary magnetic field that pervades our solar system. And that field is carried through the solar system by the solar winds, streams of electrically charged gas that are blowing outward from the sun. And this is related to sun fact number 17, and that is that the sun goes through phases of higher and lower activity, which makes up the solar cycle. And approximately every 11 years, the sun's geographic poles change their magnetic polarity. That is, the north and the south magnetic poles swap with one another. And during the cycle, the sun's photosphere, chromosphere, and coronosphere change from quiet and calm to at times violently active. Sun fact number 18. The height of the sun's activity is also known as the solar maximum, wherein solar storm activity greatly increases. Sunspots, the eruptions that are called solar flares, and coronal mass ejections are quite commonplace. The latest solar cycle started in December 2019 when a solar minimum occurred. And scientists now expect that the sun's activity will ramp up towards the next predicted maximum, which is actually expected to occur when? Next month, July 2025. We've already seen some intense solar flares from last month that released radiation and caused blackouts here on Earth. So I'm going to include a link in the description below that offers a nice, tidy summary of what's been happening in that regard. Sun fact number 19. Solar activity then can release huge amounts of energy and particles, some of which of course impact us here directly on Earth. So much like the weather on Earth, conditions in space, known as space weather, simply enough, are always changing with the sun's activities. And so space weather then can interfere with our satellites and GPS systems and radio communications and much more, crippling power grids and or even corroding pipelines, carry oil and gas, that sort of thing. And so finally, sun fact number 20. How much energy does the sun produce? Well, because its core is under this incredibly intense pressure, and the hydrogen atoms then are constantly colliding at these great speeds and fusing together to form helium, it's also releasing energy as part of that process as well. And so in just 1 second, the sun produces 118 times as much energy as the United States is estimated to use in a typical year. Every 1.5 millionths of a second, just a fraction, the sun releases more energy than all humans consume in an entire year. Again, this is according to the NASA Space Place. And then just think of your standard 60-watt light bulb. Well, the sun releases 3.86 septillion watts of energy every second. That is 3.86 times 10 to the 26th power of watts every second. Just unimaginably. So these are some of the coolest sun facts that I can share about the sun from a mathematical and a statistics perspective. And so tomorrow we're going to shift gear to the music and the arts, and we're going to be taking a vastly different approach of how we can think and write and talk and sing and dance and dream about the sun. All right, until then, and as ever, may you and yours continue to create peace in your lives, nurture love in your hearts, and dole out hugs in abundance. And hope to see you tomorrow.